astronomers have discovered an exoplanet orbiting Barnard's Star, the second nearest star system to the Sun. A report in the journal Nature claims spectroscopic measurements using the giant 10-metre Keck Observatory upon Mauna Kea in Hawaii detected what appears to be a planet about 3.2 times the mass of Earth orbiting Barnard's Star every 233 Earth days. The planet's been provisionally named Barnard Star B, with catalogue number GJ699b. Barnard Star's a spectral Type M red dwarf, located just 6 light-years from Earth, with only the Alpha Centauri triple star system at 4.3 light-years distant being closer. Its proximity to Earth has made the system a long-time target for planet hunters. Barnard Star is among the nearby red dwarfs that represents an ideal target in the search for exoplanets that could someday actually be reached by future interstellar spacecraft. The newly discovered planetary candidate's orbit would place it well beyond the snow line in the Barnard Star system, meaning volatiles such as water, ammonia, methane, and carbon dioxide would form as ice grains on this frozen world. One of the study's authors, Cristina Rodriguez Lopez, from Spain's Institute of Astrophysics in Andalusia, says the discovery means a big boost in the continuing search for exoplanets around our closest stellar neighbours, in the hope that eventually scientists will come upon one planet with exactly the right conditions for life. She says in the absence of an atmosphere, the planet's temperature is likely to be somewhere around minus 150 degrees Celsius, which makes it unlikely the planet can support liquid water on its surface, a prerequisite for life as we know it. However, its characteristics will make it an excellent target for direct imaging using the next generation of telescopic instruments. Smaller, cooler and older than our Sun, Barnard Star is among the least active red dwarfs known. And that's a good thing, because active red dwarfs, and a lot of them are considered far too violent and hostile to host planets that could support life. Red dwarfs make up more than 70% of all the stars in the Milky Way galaxy, and they're the longest living stars as well. In fact, no red dwarf that has ever existed throughout the age of the universe has yet died of old age. Although it's extremely close, being a red dwarf, Barnard Star is still too faint to be seen with the unaided eye. Astronomers were able to detect the planet orbiting Barnard Star using the radial velocity method in order to measure the host star's subtle backwards and forwards wobble caused by the gravitational tug of the orbiting planet. The problem is, detectable signals of a wobble from an Earth-sized planet tugging on their host star is incredibly faint and largely swamped by the noise generated simply by the boiling surface activity of the star itself. So astronomers followed Barnard Star for some 16 long years using the Keck telescopes. And by 2013, they had amassed some 260 radial velocities of the star. This long-running Keck planetary search program gave the authors the years of data they needed to gather in order to get enough precision radial velocity readings to begin to sense the presence of a planet in orbit around the star. The authors then combined this Keck data with additional observations from the European Southern Observatory's Very Large Telescope, or VLT, in Chile. And this allowed them to see the first real hints of what seemed to be a 230 Earth-day periodicity in the radial velocity data, indicative of a possible Earth-sized planet. At that time, however, the signals were still far too weak for astronomers to claim it as significant and publish their findings. So the authors then added an additional 45 radial velocity measurements from the Lick Observatory, 39 velocities from the Magellan 2 telescope, and additional new raw data from the VLT. In each case, this additional data helped make the roughly 230-day signal grow stronger and more significant. The final push came when the authors undertook an intensive observing campaign in 2016 and 2017, aimed at confirming the suspected planet using a new planet hunting spectrograph at the Calais Alto Observatory in Spain. And the additional data strongly confirmed the signal, removing any lingering doubt about the reality of this planet. A clear signal with a period of 233 Earth days showed Barnard Star approaching and moving away from Earth at about 1.2 meters per second. And this annual rhythmic motion can best be explained by an orbiting planet about 3.2 times the mass of Earth.